Hello, today we will continue studying propositional logic. Today we will study section E about contingent and non-contingent statements, section F of the chapter 7 on logical equivalence and contradictory, consistent and inconsistent statements. Remember that on Friday, August the 14th, you must take the exam 3 on chapter 7 of logic. Let's begin. What are contingent statements? They are statements that are neither necessarily true nor necessarily false. They are sometimes true, sometimes false. Most of the examples of compound statements that we have looked at so far are contingent statements. A truth table for a contingent statement has both true and false results in the main operator column. Now, what are non-contingent statements? They are statements such that the truth values in the main operator column do not depend on the truth values of the component parts. We will look at two kinds of non-contingent statements: tautologies that are always true and self-contradictions that are always false. So a tautology is a statement that is necessarily true. For example, horses are carnivorous or horses are not carnivorous. If we let P stands for horses are carnivorous and tilde P stands for horses are not carnivorous, then the logical form is P wedge tilde P. This is the truth table for that statement. In the first row is true because P is true in the first row. The second row is also true, and that's what it makes it a tautology. The statement is always true. And the second row is true because the negation of P is true. In the second row, P is false, but its negation is true, so the disjunction is true as well. Tautologies, although necessarily true, are sometimes referred to as empty truths. One reason why scientific hypotheses should not be tautologies is that they will offer no real information about the world, and they will teach us nothing. A scientific hypothesis that turns out to be a tautology will be obviously true, but trivial. A scientific hypothesis and the thesis statement of an essay should be a statement that could turn out to be either true or false, because only then we will learn something about the world and they will be controversial. And it will make sense to find evidence or develop arguments to support them. Now, what is a self-contradiction? It is a statement that is necessarily false. For example, the number 2 is an even number and the number 2 is not an even number. If we let P stands for the number 2 is an even number and tilde P stands for the number 2 is not an even number, then the logical form is P dot tilde P. This is the truth table for this compound statement. The first row is false because the negation of P in the first row is false. That is the second conjunct. And in the second row, the conjunction is false again because P in the second row is false. So that makes the conjunction false. This result illustrates the importance of avoiding self-contradictions when we speak or write, because they will always be false statements. Moving on to the section F of the chapter 7 of Logic by Baronet, what are logically equivalent statements? There are two truth functional statements that may appear different but in a truth table have identical columns under the main operator. Let's compare two statements. The first one is tilde parenthesis s dot h. The second statement is tilde s wedge tilde h. Now, let's create truth tables for both the statements. And let's put their truth tables side by side to make the comparison easy. The final result for the main operator shows that they are identical. Therefore, these are logically equivalent statements. In the first row, under the main operator, both the statements are false. And in the second, third, and fourth row, under the main operator, these two statements are true. That's why in every row they have the same truth value, and that makes them logically equivalent statements. Now, what are contradictory statements? They are two statements that have opposite truth values under the main operator on every line of their respective truth tables. Let's look at an example. Today is not Friday or tomorrow is Saturday. And the second statement, today is Friday and tomorrow is not Saturday. Are these two compound statements contradictory? To answer this question, the compound statements can be translated. The first is tilde f wedge s, and the second statement is f dot tilde s. We can now complete truth tables for the two statements, and we're going to put the two truth tables side by side to make the comparison easy. The results reveal that the two compound statements have opposite truth values under the main operator on every line of their respective truth tables, as you can see. Therefore, they are indeed contradictory statements. So, in the first line, the first statement is true, and in contrast, the second statement is false in the first line under the main operator. In the second line of the truth table, the first statement under the main operator is false, and in contrast, the second statement under the main operator in the second line is true. And in the third and fourth line, the first statement is true under the main operator, and in contrast, the second statement is false under the main operator in these lines. So that is what makes these statements contradictory. Now let's study consistent statements. They are two or more statements that have at least one line on their respective truth tables where the main operators are true. Let's analyze the following example. The first statement is R wedge B, and the second statement is R wedge tilde B. Let's create truth tables for these two statements. As you can see, in the first and second lines, these two statements are true. So that makes the two statements consistent. As I said, the truth table comparison shows that the main operators are both true for line 1 and line 2. Therefore, these two statements are consistent. Now, what are inconsistent statements? They are two or more statements that do not have even one line on their respective truth tables where the main operators are true at the same time. They can be false at the same time. Let's analyze this example. The first statement is my car ran out of gas and I do not have money. The second statement is my car ran out of gas if and only if I have money. Translating them, we get first C dot tilde M, and 2, the second statement translated is tilde triple bar M. Here are the truth tables. This is a set of inconsistent statements because there is no line where the main operators are both true. Since both the statements are false on the line 3, they are not contradictory statements. Remember that contradictory statements must have the opposite truth value under every line of their truth tables. In this case, in line 3, they have the same truth value, that is false, So they are not contradictory, but they are inconsistent statements. That's all for today. On Friday, August the 14th, you should take your exam 3 on the chapter 7 of the textbook. Also remember to complete exercises 6, 12, and 18 of exercises 7E, exercises 2, 8, 15, and 24 of exercises 7F1, exercises 2, 8, and 15 of exercises 7F21, and exercises 2 and 8 of exercises 7F22. Submit your complete answers on Brightspace by tonight at midnight. Have a good rest of the day.